Hello everyone, myself Dr. Santiago Kundu. I welcome you to this lecture of subcomputing technique. This is the second lecture of module 4. Till now, we have discussed module 1, 2 and 3. In module 4, we have already discussed the introduction part of genetic algorithm and we have seen the comparison between the Darwin principle, that is the evolution of natural species, and the genetic algorithm. So before getting into GA, it is necessary to explain few terms. So first one is that chromosome, that is a set of gene. So a chromosome is a set of genes. So a chromosome contains the solution in form of genes. So suppose there are two solutions. Suppose you are going to solve these equations. X plus y equal to 10. So we assume x equal to 6. We assume y equal to 4. So that 6, 4 is the 6, 4, 6 and 4 are the genes, and together 6, 4 can be written as chromosome. So gene is a part of the chromosome. So a gene contains a part of the solutions. It determines the solution. Like for example, 164, that as for example 1716, as for example 16743 is a chromosome, and this individual number, that is 16743, are its genes. So individual means the same as chromosome, so that is one individual 64. Population is the number of individuals present with the same length of chromosomes. Fitness is that the value assigned to an individual based on how far or closer an individual is from the solutions. Greater the fitness value, better the solution it contains. So fitness function is that a function that assigns fitness value to the individual. It is problem specific. Selection. So selecting individual for creating the new generations. Crossover is that taking two fit individual and then intermingling their chromosomes to create new individuals. Mutation is that changing a random gene in an individual. So try to understand the pseudo code. So first is that we initialize populations with random candidate solutions, evaluate each candidate. We need to repeat the steps until termination condition is satisfied. So we need to do, we'll select parents, crossover, that is the recombining pair of parents, mutation, that the resulting offspring and with certain change, then again selecting for the next generations, and we'll stop these things when we got the solutions. So that is a simple genetic algorithm. We need to do the we need to do the initialization of the populations, calculate fitness function. While fitness value is not equal to the optimal value, we need to do the selections, we need to do the crossover, that is reproduction, that is propagate favorable characteristics. We will do the mutation, that mutation calculate the fitness functions. Mutation means slight change in the offspring. Search space. In solving problems, some solutions will be the best among others. The space of all feasible solutions among which the desired solution resides is called search space. That is also called the state space. Each point in the search space represents one possible solution. Each possible solution can be marked by its value or fitness for the problem. The GA looks for the best solution among a number of possible solutions represented by one point in the search space. Looking for a solution is then equal to looking for some extreme value, that is minimum or maximum, in the search space. At times, the search space may be well defined, but usually only a few points in the search space are known. In using GA, the process of finding solution generate other points, that is possible solutions, evolution proceeds. Genetic algorithm begins with a set of solutions represented by chromosomes, that is called populations. Solutions from one population are taken and used to form a new population. This is motivated by the possibility that the new population will be better than the old one. Solutions are selected according to their fitness to form new solution, that is offspring. More suitable they are, more chances they have to reproduce. So this is repeated until some condition, that may be the number of populations or the improvement of the base solution, is satisfied. So outline of the basic genetic algorithm: we start generate random populations of n chromosomes, that is suitable solution for the problem. Evaluate the fitness effects of each chromosome X in the population, that depends on the problem. New solution: create a new population by repeating following steps until the new population is complete. So we need to do the selection. So select two chromosomes from a population according to their fitness. Greater the fitness, bigger the chance to be selected. Crossover. With the crossover probability, with this term we will explain crossover probability and mutation probability. So with the crossover probability, crossover the parents to form new offspring. If no crossover is performed, offspring is the exact copy of parents. Mutation. With the mutation probability, mutate new offspring at each locus, that is position in the chromosome. Accepting. Place a new offspring in the new population. Replace, use a new generation population for a further run of the algorithm. If the end condition is satisfied, stop and return the best solution in current populations. Next is that if not, then go to the step 2. So this part is the step 2. We need to calculate again the fitness value and do all these steps. So note is that the genetic algorithm performs is largely influenced by two operators called crossover, that is creating of new offspring, mutation is certain change in the offspring. These two operators are the most important parts of genetic algorithm. Now encoding algorithm. Before a genetic algorithm can be put to work on any problem, a method is needed to encode potential solution to that problem in a form so that a computer can process. One common approach is to encode solutions as binary strings. Sequences, that is binary strings, means the one common approach is to encode solution as binary strings, that is sequence of ones and zeros, where the digit at each position represents the value of some aspect of the solution. Example, a gene represents some data, that is the eye color, hair color, sight, etc. So gene look like these things: 1 1 1 0 1 0, and chromosome is the combination of gene 1, gene 2, gene 3, gene 4. Let's try to understand one thing is that suppose we are solving a solution like 3x square plus y square equal to 10. So here x can take a value something like 0 to 8, y can take a value something like 0 to 4. So here we assume x equal to 7. We assume x equal to 7 and y equal to 3. So 7 binary can be written as 1 1 1. 3 binary, the y equal to 3 binary number can be written as 0 1 1. So these are the gene. 7 and 3 are the gene, whereas 1 1 1 0 1 1, this is a chromosome. So a chromosome should in some way contain information about solution which it represents. In thus requires encoding. The most popular way of encoding is the binary string, like chromosome 1. It may be 2 variable, maybe 3 variables. Suppose if it's 3 variables, so that is variable 1. This is variable 2 and this part is variable 3. It may be like that. Each bit in the string represents some characteristics of the solutions. So there are many other ways of encoding. As for example, encoding values as integer or real number for some problems, or some permutation for the case of traveling salesman problems. So that is TSP. The virtue of this encoding method depends on the problem to work on. Now try to understand the crossover points. So for the case of binary encoding, so a commonly used method for crossover is called single point crossover. In this method, a single point crossover position is chosen at random and the parts of the two parents after the crossover positions are exchanged to form two offspring. So here that is single point. So we are assuming parent 1, what is given in the example, parent 1, parent 2. So parent 1 is 1 0 1 1, then 1 1 1. Parent 2 is that 0 1 0 1 0 0 1. So take a position the after the fourth bit, after take a position that after the fourth from the most significant bit. So that is now need to exchange these two. Exchange this part come to here and this part goes there. So the new offspring 1 will be like that, 1 0 1 1, and this part is 0 0 1, this is 0 1 0 1, this part is 1 1 1. So that is offspring 1 and offspring 2. Now multi-point crossover. So it is a generalization of single point crossover introducing a higher number of cut points, 2 cut point, 3 cut point, like that. So here parent 1 and parent 2 is that parent. So now here parent 1 is that 1 0 0 1 0 1 1 1. Parent 2 is that 0 1 1 1 0 0 0 1. So after the third positions, after the fourth positions, so now offspring 1 and offspring 2. So this part is 1 0 0, this will interchange, so that is 1 0 0, this part is 1 1. That is 0 1 1, this comes this point and it is 0 1. So that is offspring 1 and offspring 2. Now another is that uniform crossover. So it does not use cut points, but simply uses a global parameter to indicate the likelihood that each variable should be exchanged between two parents. We will discuss in further slides. So now parent 1 and parent 2 is that 1 0 1 0 0 0 1 1 1 0. Parent 2 is that 0 0 1 1 0 1 0 0 1 0. So this underlay represents will exchange. Will exchange here, will exchange here, and will exchange here. So offspring 1, offspring 2 will exchange. So it is now 0 1. This is exchange 0 1. This is exchange 1 0 0 0. This is not exchange. This is also not exchange. Now it is 0 1 0 1 1 0. So that is basically the offspring 1 and offspring 2. So that is uniform crossover. Now example. So a budget airline company operates 3 airplanes and employs 5 cabin crews. Only, only one crew can operate on any plane on a single day, and each crew cannot work for more than 2 days in a row. The company uses all planes every day. They will all use all 3 planes. They will use all 3 airplanes. So a genetic algorithm is used to work out the best combination of crews in any particular day. So suggest what chromosome would represent an individual in this algorithm. So on each day, a solution is a combination of 5 cabin crews assigned to 3 airplanes. Thus, we could encode in different ways by different genes. So genes of the crews are A, B, C, D, E. So these are the genes. So we need to choose 5. We need to choose. So we need to choose 3 cabin crews from out of 5. So that number of ways is 5 C3. So that is 5 factorial, 3 factorial, 2 factorial. So you will get it 10 solutions. So there will be solution 1, 2, 3, 4 up to 10. So solution 1 A, B, C. So that is a chromosome. second is ABD, third is CDE. So in this case, each position in the chromosome corresponds to a plane. Another encoding is possible for the same problem. For example, we could encode if a crew is assigned on a plane by number 1. So it does not matter which plane it is. And 0 if the crew has a off day or day off. So gene should be work day and off day. So 1 and 0. So thus in we can use chromosome of 5 genes which corresponding to a particular crew with 0 or 1 representing if a crew is representing if a crew is at work or has a day off. So ABC can be represented as A is 1, B is 1, C is 1, D is 0, 0. So that is a chromosome. Chromosome solution 2 is A, B, 0, D's work is off. Here it is 0, 0, 1, 1. So that is the example of binary encoding. So solution 1 represents these things, solution 2 represents these things, and it is represents C, D, E. So as you can see, the same problem can be encoded in different ways. So we are going to solve one example. Example is that we are going to solve one equation which is that x plus y plus z equal to 12. So which x belongs to 0 to 7, y belongs to 0 to 7, z belongs to 0 to 3. We can deal with the real number, but right now we are assuming x plus x, y, z. Right now we are assuming x, y, z belongs to the natural number. Okay, so we are assuming that x equal to 6, y equal to 5, z equal to 2. So here the binary encoding you can write it 1 1 0, you can write it 1 0 1, you can write it 0 1 0. So here one chromosome is that 1 1 0 1 0 1 0 1 0. So you can check its solutions 1. You can check another solution set. Suppose x equal to 7, y equal to 4, z equal to 3. So solution 2 can be written as 1 1 1 0 1 0 0 1 1. So we can do the crossover and mutation, and we can solve these questions to get them. We can solve these questions where it is not possible to solve in other methods. So conclusion is that today in this class we have understood working principle of genetic algorithm. We have understood the encoding. We have understood the crossover, etc. So today question is that so assuming any two chromosome so today question is that assume any two chromosome just like 1 1 1 0 0 1 0 1 0 1 0 0 0 0 1 1 0 0. So after that you by using crossover find a new gene. Find new chromosomes by using crossover. And new chromosomes by using crossover. So these are the reference of today's class. Thank you.